Engineering Mechanics Static Lecture 20. So for the present lecture, we are going to go into detail on this section, which is method of composition under the subchapter of center of gravity and centroid analysis. Okay, we already go through for this one, method of integration, in the previous lecture, which is lecture 19. Okay, so for this one we are going to go for this method, which is method of composition. So these are the objectives. The first one is the location of the location of center of gravity, and then the second one is the location of center of mass, and then the third one is the location of centroid using the method of composite bodies. Okay, so the next one is, this is for the applications. The I-beam is commonly used in building structure. When doing a stress analysis on an I-beam, the location of the centroid is very important. So how we can easily determine the location of the centroid for a given beam shape? So talking about centroid analysis, we basically have two types of analysis. Okay, centroid analysis can be divided into two types. The first one is integration method, and the second one is composite method. Okay, so this one we already learned previously. So this one particularly for the uneven shape. Let's say we have a shape like this, or like this one, or whatever shape. So we need to do the integration along this shape to get the amount of the force by calculating the area, and then after that we are going to find the x bar and y bar to find the location of the gravitational force. Okay, somewhere around here. Okay, that's for integration method. You use the integration okay, y dx and x dy. Okay, for composite method, this is much simpler actually compared to integration method, because you are analyzing this simple geometric shape, but it is a combination of simple geometric shape. For example, you have a shape like this. Okay, this is actually a combination of shape of trapezoidal and rectangle. Okay, another one shape is like this one. Okay, so this one for triangle and rectangle. Okay, so composite shape is actually to find the total amount of the gravitational force. For this one you need to do the integration, right? But this one you just do the summation. Okay, summation. Let's say you find this area for trapezoidal and find this area for rectangle. So the summation of the area for trapezoidal and the rectangle is the amount of the area of the whole system. Okay, same goes to when you want to find the location of center of gravity. Using the same formula when you want to calculate the integration method. If you still remember, we using x bar and y bar is equals to integration of dy. Sorry, there's an x bar here, our dy. Okay, So this one is y bar dy over dy. Okay, this is for integration method. For composite method, we need to change the integration into summation, just like this. Just the one when we want to find the area or the amount of gravitational force. Okay, so for this one, you're gonna write the question will become x bar is equals to summation of x bar weight. Okay, so the differential here you need to remove because this is not integration. This is a summation over summation of weight. Okay, so same goes to y bar. Y bar is equals to summation of y bar weight over summation of weight. Okay, so frankly speaking, you need to find let's say this shape. If you want to find the center of gravity of this shape, you need first find the center of gravity for each shape first. Okay, for example, find the center of gravity for the rectangle one first. Okay, and then you will get the s bar and y bar for the rectangle, and then find the center of gravity of the triangle. Then you will get the center of gravity for the triangle. Okay, so to find the center of gravity for the whole shape or the total shape, so you need to sum up both center of gravity from the each shape. Let's say which means that center of gravity for x bar for rectangle, okay, sum up with center of gravity for triangle. Okay, so this one you will get the total x bar. So this total x bar is a center of gravity of the whole shape. Okay, let's say, okay, we have the x bar is at this location. Let's say x bar. Okay, same goes to y bar. So sum up both y bar and then you will get the total y bar. Okay, so let's say in this location. Okay, so this new location of x bar and y bar is for the total centroid of the shape. Okay, so when you get the question of composite body centroid analysis, so this is the step that you need to do. Okay, the first one is to divide the body into pieces that are known shapes. Okay, if there is a holes in the body, so you need to consider it as a piece of negative weight or size. Okay, the visible body is positive and the whole one is negative. Okay, please remember that. Okay, the second one is make a table with the first column for segment number, the second column for weight, mass or size depending on the problem, the next set of column for the moment arms, and finally several column for recording result of simple intermediate calculation. Okay, the third one is to fix the coordinate axis and then determine the coordinate of the center of gravity or centroid of each piece. Okay, and then fill in table. Okay, so you need to find the center of gravity or of centroid for each of the shape. Okay, and then the last one, sum the column to get x bar, y bar, and z bar. Use formula like this formula. Okay, so after you get the center of gravity of each piece, then you sum up all the center of gravity to get the total center of gravity of the total shape. Okay, so this approach will become clear by doing example. Okay, after this we are going to go for the example. Okay, that's it.